Hello everyone, this is Maurizio, editor-in-chief of Power Electronics News, and welcome to this new episode of Wind Down Friday. Today, our guest is Chang Ting-Yan, CEO of Fast SiC Semiconductor. Thanks a lot for being here, Cheng-Ting. How are you?
Hi, I'm good. Thank you. Thank you for having
Thank
me
you. Thanks a lot for your
here.
time. Where are you located?
I'm located in Hsinchu, Taiwan.
Taiwan. Nice place. So let's start. So I have prepared a couple of questions for you. So
Yeah.
you have a great career. So from pioneering silicon carbide shortly diodes to holding 8.4, I guess, patents. So please correct me. So your journey is great. It has been something of inspiring. So what originally drew you to power semiconductors and device design?
So it's just, I think I would say it's just occasional because I was with work for research institute in Taiwan called ITRI, which is the TSMC spin-off from ITRI like 30 years ago.
Yep.
And so I started working on power semiconductor, especially in silicon carbide, like 12 years ago, when back then I was originally working on memories. And then we have a project with some industry who they have interest to develop the silicon carbide. So that's why I moved to this project and then started to study the power semiconductor. Yes.
So you have worked across research institutes, startups, global labs. So what inspired you to take the leap and so the lead as well and found Fast SiC Semiconductor?
Um, I think this because in Taiwan we have very strong power supply industry. We have like Delta Electronics and we have Lion. Those are leading power supply companies, and the silicon carbide is the material that people have some very high expectation that can uh, provide much better performance than silicon, but it's expensive, right? Back then it's more expensive than now. So and because back then the industry is traditional, they are IBM models. So like Infineon ST, they have their own fab, but like 10 years ago, they started to have some foundries like IC industry. They have foundry that can provide manufacturing services to these devices. So I think that's a good chance we can do something and we can maybe split up make people use these good devices if they can be provided at a more reasonable cost. So that's the reason we take a try. Yeah.
Yeah, sure. So you have worked across different countries, so Taiwan, United States, Sweden, Japan. So how have these international experiences, shaped your technical vision, your leadership about also your current company?
I think yeah, I think I like traveling, so at least it's very good experience for me to have chance to work in these countries, and also I have known people from different countries and different cultures. So I think that's good, and because this like semiconductor industry is a really global industry, right? So you don't have just local customers, you have customers from different countries. So I think that experience is very helpful for me in this right now for business.
So outside your work in semiconductor, as the philosophy of Wind Down Friday, what are some of your favorite hobbies to recharge your batteries?
Okay, what I like trekking, so
Hmm.
so I like I have been go to Nepal for like antenna checking, and in my casual time, so I like to trekking with my wives, and I also like to swim. So that's my habits. Yes.
So, from your biography, you also translated 14 books, I guess, so including
Yeah.
8 from Japanese. So, what sparked your interest in book translation? So, and how this would connect with your approach in engineering?
I don't know if there is direct connect to my work, but I like Japanese culture. I like Japanese animation. So since when I was a student, so that's why I started to start Japanese, and because Japanese people are mostly they are kind of shy. So if you can speak Japanese with them, they are usually more open to have some conversation with you. So so that's I think also a lot of languages are I don't know usually you don't know it's not directly to your work. You don't know
Yeah.
is there any direct benefit, but I think if you can talk casual with people, that's helpful in many ways. So
are you speaking and writing in Japanese?
yeah, I'm speaking, but in writing is more difficult. But translating is writing in Chinese, right? So just I can read Japanese, so that's easier. But I writing in Japanese is more difficult. I can write, but I don't usually write long articles.
So
Just
looking
emails.
forward, yeah, thank you, thank you. So looking forward, so talking about silicon carbide, what's next for you? What's next for Fast SiC Semiconductor? Any goals emerging specific tech areas that you are particularly excited about? So tell me more.
Okay. So right now, I think you may already know that silicon carbide, the cost of silicon carbide has dropped significant, right? So we are seeing the widespread adoption of silicon carbide power devices is going to happen, and actually in not like these major IDMs, we also have some products that can be used in smaller power applications, including PC power supplies, adapters for laptops, and even mobile phones. And so we think in these applications, silicon carbide also have some very good chance because we are expecting the cost of silicon carbide MOSFET at 650-volt ratings. The cost is already very close to the silicon superjunctions. So we think if we can give some values, some better EMI, better performance, and better thermal, many of our customers are very happy to use these devices if they can be provided at a similar cost. And also because for silicon carbide, people are talking about EVs and some renewable energies. But for us, EV is like a long-term strategy, right? So car OEMs, they have to take a long time before they can really use our devices from our company in their cars. So we are seeing many opportunities in like lower power applications, also in some server power supplies. We have already have customers in Taiwan. They use our devices in server power supplies for NVIDIA. And they use I think quite a lot high volume for this server power supply. So I think these are good opportunities for us. Yes.
Good. Do you see a competition between GaN and silicon carbide in the future?
Yes, but we look at competition is it's good because if you have competitions, you push yourself to move forward and to try to provide better devices. So of course we are seeing competition from gallium nitride, but because gallium nitride is, I mean, the mainstream gallium nitride devices right now is later devices is GaN, right? And because it's later devices, so in terms of scaling potential, we believe that silicon carbide has higher potential to continue to be scaling down, which means it can make chips smaller, which means potentially the cost is going to be lower. So I think silicon carbide still have a good chance in the majority of power supply applications, unless some of applications that really need very, very high silicon frequencies. Maybe GaN has absolute advantage, but for most power supply applications, they just need several 100K plus switching frequencies. In these applications, I think silicon carbide MOSFET is going to perform very good compared to GaN.
Good. So thank you, Chang Ting-Yan, CEO of Fast SiC Semiconductor. Thanks a lot for this interview. I wish you a great weekend and a great day, and stay in touch. See you next week, probably at PCIM.
Thank you. Thank you for your invitation. Thank you.
Thank you. Have a good day.
You too.